Professor Brian Fry believes the Komodo dragon's venomous bite is merely a myth. The scientist from the University of Queensland in Australia proved that the deadly bite of a Komodo dragon was not caused by the bacteria contained in the prehistoric reptile saliva. Along with a team of researchers from the United States, Fry discovered that the bacteria in the Komodo's mouth did not differ from any other carnivore. Fry's new findings clash with the preconceived notion of other scientists that believe the bacteria in a Komodo dragon's saliva was the key to killing its prey. Professor Fry said Komodo attacks on pigs and deer were successful, with about 75% bleeding out within 30 minutes and a further 15% dying in 3 to 4 hours from venom in the dragon's salivary glands. In contrast, the much larger water buffalo invariably managed to escape from attacks but were left with deep wounds to the legs, from which they later died. Snakes are limbless predators, and many species use venom to help overpower relatively large, agile prey. Snake venoms are complex protein mixtures encoded by several multilocus gene families that function synergistically to cause incapacitation. To examine venom evolution, we sequenced and interrogated the genome of a venomous snake, the King Cobra, Ophiophagus hanna, and compared it, together with our unique transcriptome, microRNA, and proteome datasets from this species, with data from other vertebrates, in contrast to the platypus, the only other venomous vertebrate with a sequenced genome. We find that snake toxin genes evolved through several distinct co-option mechanisms and exhibit surprisingly variable levels of gene duplication and directional selection that correlate with their functional importance in prey capture. The enigmatic accessory venom gland shows a very different pattern of toxin gene expression from the main venom gland and seems to have recruited toxin-like lectin genes repeatedly for new non-toxic functions. In addition, tissue-specific microRNA analyses suggested the co-option of core genetic regulatory components of the venom secretory system from a pancreatic origin. Although the King Cobra is limbless, we recovered coding sequences for all HOX genes involved in amniote limb development, with the exception of HOX12. Our results provide a unique view of the origin and evolution of snake venom and reveal multiple genome-level adaptive responses to natural selection in this complex biological weapon system. More generally, they provide insight into mechanisms of protein evolution under strong selection. Most snake species, around 70%, are considered oviparous, which means they lay eggs. The eggs, like those of birds, must then be incubated, or at least kept warm, until the hatchlings are fully developed and ready to emerge from the shell. From the Colubridae family, almost all of its members lay eggs, including rat snakes, king snakes, grass snakes, and other species. The mambas, cobras, adders, and many other members of the Elapidae family are also oviparous. The fact that pythons remain with their eggs until they hatch, in contrast to many other snakes, is part of what makes them unique. Not only do they stay with them to keep them warm, but they're also there to protect them from potential predators. All of the eggs may not be laid for 2 or 3 hours. The eggs are frequently partially covered in the sand after being laid. Eggs begin to hatch within 52 to 60 days. Unfortunately, there are instances where the eggs are temporarily left alone. A compilation video on YouTube shows just how quickly Komodo dragons and monitor lizards can steal python eggs. The King Cobra is fast, agile, and has much more powerful venom. If it ever had to fight a Komodo dragon, it could likely strike before the dragon could kill the snake. That said, Komodo dragons are much heavier and more powerful than cobras, so a Komodo dragon could kill the snake relatively easily if it could catch it before being bitten. Though powerful, Komodo dragons have a definite disadvantage when it comes to speed. The King Cobra would likely evade any attack it might make and bite the dragon repeatedly until its venom takes effect. Komodo dragons are voracious eaters that prey on large mammals as well as birds and other reptiles. Young Komodo dragons regularly feed on smaller prey like snakes. However, it is not uncommon for even larger adults to eat snakes such as the cobra, which is regularly found in their grassy habitat. The King Cobra is the largest snake in the world, and the Komodo dragon is the largest lizard. Both reptiles have very different styles of attacking prey. A Komodo dragon would overpower a King Cobra in a fight. Komodo dragons are large monad.